Good evening, sir. My name is Kumar. I'm from Amos Lot of Design Patterns, and this is my digital assignment one. Uh, the introduction part of my topic is uh, the design pattern identifies and participating classes and instances, their roles and collaborations, and the distribution of responsibilities. Each design pattern focuses on a particular object-oriented design pattern or issues, and a design pattern name abstract and identify the key aspects of a common design structures that make it useful for creating a reusable object-oriented design. And coming to the how design patterns solve design patterns, I'm explaining about finding appropriate objects, determining object granularity, specifying object interfaces, specifying object implementations. And coming to the finding appropriate objects, object-oriented programs are made up of objects. An object packages both data and procedures that operate on the data. The producers are typically called methods or operations. An object performs an operation when it receives a request or message from a client. Clients are the only way to get the object to execute an operation. Operations are the only way to change an object's internal data. Because of these restrictions, the object's internal state is said to be encapsulated. It cannot be accessed directly, and this representation is invisible from outside the object. The hard part about object-oriented design is decomposing a system into objects. The task is difficult because many factors come into play: encapsulation, granularity, dependency, flexibility, performance, evaluation, reusability, and on and on. They all influence the decomposition, often often in conflicting ways. This is the part of finding appropriate objects. And coming to determining object granularity, objects can vary tremendously in size and number. They can represent everything down to the hardware or all the way up to entire applications. How do we decide what should be an object? Design pattern address this issue as well. The facade pattern describes how to represent complete subsystem as objects, and the flyweight pattern describes about how to support huge number of objects at the finest granularity. And coming to the specifying object interfaces, specifying object interfaces, every operation declared by an object specifies the operation name, the object it takes as parameters, and the operation return value. This is known as operations signature. The set of all signatures defined by an object operations is called an interface to the objects. An object interface characterizes the complete set of requests that can be sent to the object, and any request that matches a signature in the object interface may be sent to object. A type is a name used to denote particular interface. We speak to an object as having the type window if it accepts all requests for the operation defined. In the interface name window, an object may have many types and widely different. Objects can share a type. Part of an object's interface may be characterized by one type, and other parts by other types. Two objects of the name type need only share parts of their interfaces. Interfaces can contain other interfaces as subsets. We say that a type is a subset of another if its interface contains the interface or its supertype. Often we speak of a subtype inheriting the interface of its supertype. And consider a framework for application that can present multiple documents to the user. Two key abstractions in this framework are the class applications and document. Both classes are abstract, and the client have to subclass them to realize their application specific implementation. To create a drawing applications, for example, we define the classes like drawing application and drawing document. The drawing application is responsible for managing documents and will create them as required. When the user selects open or new from a menu, for example, because the particular document subclass to instantiate is application specific, the applications class can't predict the subclass of document to instantiate the application. Class only knows when a new document should be created, not what kind of document to create. This creates a dilemma for the framework must instantiate classes, but it only knows about abstract classes, which it cannot instantiate. The factory method pattern offers a solution. It encapsulates the knowledge of which document subclass to create and moves this knowledge out of the framework. This is the uh, how patterns solve design patterns. And there are some types of three types of design patterns: creational pattern, structural pattern, and behavioral patterns. Coming to creational pattern, these patterns are designed for class instantiation. They can be either class or creation patterns or object creation patterns. And structural creation patterns are designed with regard to class structure and composition. The main goal of these patterns is to increase the functionality of class involved without changing much its composition. And behavioral patterns are designed for depending on how one class communicate with others. Every pattern consists of intent, motivation, applicability, structure, participants, collaborations, consequences, and implementation issues. And coming to the factory pattern, the intent is define an interface for creating an object, but let subclasses decide which class to instantiate factory method. Let's a class differ instantiate to subclass. This means the subclass has to decide on which class has to instantiate, and factory method differ from instantiate to subclass. And how factory pattern works means uh, firstly what the factory pattern does is it replaces the object creation using new by a factory method. This factory method in turn creates objects for us using new. So the question arises, isn't the removal of new from one part of code just to add it to some other part of the code pointless? Consider this: now we have a separate method to create objects. Hence, this method can be used by different classes to create objects at runtime. Our code that will further use these objects is called as the client code. This client is unaware of the exact type and creation process of the object. Thus, it treats all the objects as they are of the base type, which means in our example, our client will not know whether the object it receives is a object type email or SMS. It will treat all the objects as if they are objects of type notification. An abstract can have one of the several possible implementations. The usual way to accommodate them is to use inheritance. An abstract class defines the inheritance to the abstraction, and concrete subclass implementation it in different ways. But this approach isn't always flexible enough. Inheritance binds an implementation to the abstraction permanently, which makes it difficult to modify, extend, and reuse abstractions and implementation independently. Consider the implementation of a portable window abstraction in the user interface toolkit. This abstraction should enable use to write applications that work on both X window system and IBM's presentation manager. For example, using inheritance, we could define define a define an abstract class, window and subclasses X window and PM window that implement the window interface for the different platforms. But this approach has two drawbacks. It's inconvenient to extend the window abstraction to cover different kinds of windows or new platforms. Imagine an icon window and subclass of window that specializes the window abstraction for icons. And to support icon window for both platforms. We have to implement two new classes, X icon window and PM icon window. First, we will have to define two classes for each kind of window. Supporting a third platform requires another new window subclasses for every kind of window. And this is the structure of the factory pattern. And collaborations are creator relies on its subclasses to define factory method so that it returns an instance of the appropriate concrete product. And implementation issues are two major varieties: parameter factory methods, language specific variants and issues, using templates to avoid subclasses, and naming conventions. And coming to bridge pattern, the intent of bridge pattern is decouple and abstraction from its implementation so that the two can vary independently. And coming to the real life, I want to explain the bridge pattern with a real life example. For understanding bridge pattern, so I am taking the real life example. It is very common nowadays whenever we purchase any smartphone, we get a charger. The charger cable nowadays can be separated, so we can use it connect as a USB cable to connect other devices. The adapter and the cable are separated nowadays. Those chargers are available. Almost in every application, we need to store data. Let's assume we need to store in two different storage mechanisms, file and database. Also, before we use store, we have to process the object validation, set some data. Normally, we go with separate classes to do this process as shown below. We have to code for we have to code for storing student object into file and database. This is an common scenario. Uh, now let's assume we need this is a common scenario that we need to add code to the same thing for a course object also. Then we will need two more classes like a save course in file and a save course in DB database. Also, if we need to add new storage system like another database or network call, then we will have to create a new class for each type, like or our example student class and course class. This will keep increasing for each new class and storage type. Which pattern simplifies the above scenario for helping with reusable code. Then we use in the core functions. This will solve the problem of adding new tables like course. After that, we just need one save course. This class will use storage service to store into specific storage systems. And the participants of the structure are abstraction, refined abstraction, implementer, concrete implementer. And consequences are improved extensibility, hiding implementation details from clients. We have to hide implementation details from client. We don't want to share our implementation details with the client. Client just need the our only output of the interface only, not about the implementation part. The implementation issues are only one implementer will be there, creating the right implementer object, sharing implementers, using multiple inheritance. This is the our topic upon the digital assignment one. Thank you, sir.